Good morning, stats. All right, so we're going to take a look here at 1.9, describing location in a distribution. And in this, we're talking about percentiles. You may have heard this before, whether your parents were talking about it or you check this every time you were at the doctor to get a yearly checkup, but they talk about percentiles in height and weight, head size, all sorts of different things like that, especially the younger you are, the more that is. But what that does is compare you to the rest of the people or in your age. So we're talking about percentiles here, how to find them, how to locate them, and what they mean. So the first objective here is to find and interpret a percentile in a distribution. And it's important here to look what is a percentile. So the first definition here is percentile. And all that is the percent of values that are less than an individual data. Okay, so it's a percent, and this is really important. It's less than an individual's data value. So notice it's not in the, it's at the. So very important to notice here, and we're going to take a look at this problem specifically here in a moment. But to look at all the data, you got to make sure you're careful with your language when we're talking about percentile. It's at the percentile. It's not in the percentile. And I'll talk a little bit more about that as we do the examples. But notice when we talk about percentile and quartiles, and they're pretty much the same thing. Okay, 25th percentile is in the first quartile. The 50th percentile is the median. The 75th percentile is the third quartile. So again, just depending on what type of data we're looking at. Again, if the data is more skewed, we want to talk about we look at the median and the Boston whiskers. If it's a little bit more symmetric, then we're going to go ahead and look at the standard deviation. So just so you got to remember, when we're talking about statistics, you have to pay attention to what we are discussing and what is in the percentile. A high percentile is not always a good thing. If we're talking about blood pressure, if you're at the 90th percentile for blood pressure, that means your blood pressure is higher than 90% of everyone else around. So that's not a good thing. So you have to understand and keep it in context with what we're talking about. And it's the same thing with having a low percentile. Sometimes a low percentile can be good. Sometimes it can be not so good, depending on the data that we are discussing. So very important here that we use the correct vocabulary at the percentile, not in the percentile. And again, I'll discuss that as we go over this next example in the next slide here. Okay, so as we're moving forward and we take a look at this, it says refer to the dot plot of scores on Mr. Pryor's first statistics test. So you can see the scores, you can see the dots, and it's asking you to find the percentile for Norman, who scored 72. So if we look at the percentile and we look at the scores of 72, if that's 65 and that's 70, that would be 67.5. That's 70, that's 75, that would be 72.5. So I am specifically talking about this dot right here, okay? That would be Norman's score right here, okay? I'm just going to go ahead and put a little arrow at this. This is Norman's score. So I want to know and find the percentile for Norman. How many did he score better than? And what we do is we count every single dot that's to the left of Norman. So it'd be everything over here. Well, clearly we can see that there is only one dot. Okay. So what we do is we take that dot, that number, and we're going to divide that by the total number of tests taken. So there was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So there were 25 total tests. Notice I did not include Norman's score. It's everything to the left of that score. So what I do here is take 1 times 25 and multiply that by 100. So we can go into Desmos, 1 over 25. We can multiply that by 100, so times 100, and that's going to give us 4. Okay, so we are in the 4th percentile. which means that Norman scored better than 4% of his class. Okay, he is at the fourth percentile, not in the fourth percentile. Notice again, I did not include that. So we say at the fourth percentile when we do that. So the next question here says Maria's test score is at the 48th percentile of distribution. Okay, so at the 48th percentile. Interpret this value in context. What score did Maria earn? So how would I find this? Okay, so again, the 48th percentile. So what we need to do is find out what the percentile was. Where does that put us? The 48th percentile. And what we do with that is we had 25 total students in the class, okay, and Maria scored better than 48% of them. So we would take 25 and we would multiply that by 0.48. Okay, so again, just going back up to my Desmos calculator, 25 times 0.48, because that is the 48th percentile, and that is equal to 12, a nice round number here. So going back to that, we say that this is equal to 12. Okay, again, where did I get 25 from? That was the total number of tests, and the 48th percentile means she scored better than 48%. So interpret this value in context. What does this mean? It means Maria scored better than 12 of her classmates. Okay. Now, if we go back to the data, it wants to know what score did Maria earn. So if she scored better than 12, that would mean hers would be the 13th dot. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And when they're stacked up here, you don't know whose is who, but it's one of those two right there. So the score would be an 80% is what Maria scored, or 80 points. I don't know that these are in percentages, but she scored 80 points on that test. Okay, so again, that's how you kind of use the data. Oops, let me go back to that. So again, the two types of questions I could ask you from a data point are find the percentile. What do? We add up all of the values to the left of, and we divide by the total, and that gives us the fourth percentile. And again, when we do that, we say it's at the fourth percentile. Let me just make sure I write that down. At the fourth percentile. Not in the fourth percentile because his data wasn't included. And then it says to find the 48th percentile, we take the total and we multiply it by the given percentage, and that will give us the value we're looking for. Okay, that's the interpretation of it. Then we can count to find the score or the data point that we are looking at. Okay, the next slide talks about standard score, standardized score, or the Z-score, and this is going to be very important for us as we kind of move forward here. So we're going to use this a lot when it comes to later on down the road. And again, we're talking about standard deviation, and what does the standard deviation means when we go back to finding the mean and talking about the mean as the middle value. Standard deviation kind of takes us that, like how far something is away from the mean. Okay, so this standardized score tells us how many standard deviations from the mean an individual falls and in what direction. So again, when we're talking about the Z-score, it could have a positive or a negative value. So this right here would be above the mean, and a negative would mean it's below the mean. Okay. So we take the value, so the value that we're looking at, we subtract the mean, and we divide it by the standard deviation. The nice thing is we get the mean from the stats applet. We get the standard deviation from the stats applet. So not a ton of work to do because the stat applet helps us out quite a bit. But where does this kind of come into play? If you take a look at this next slide, and there's no math here, it's just says find and interpret a standardized score, looking at Z-scores. So observed values are standardized to express them on a common scale. Again, we're observing values on a standardized scale so that we can actually compare two sets of data. If I have two people at age 7, Jordan is 51 inches tall. She has a Z-score of 1. At age 9, Zane is 54 inches tall, and he has a Z-score of 0.5. Well, obviously, most of the time, a 9-year-old is going to be taller than a 7-year-old. And at certain ages, females may be taller than males up until a certain point, or vice versa. Okay. But what we're doing is we're ignoring the age and we're ignoring the male female. And what we're doing is comparing those data by looking at the standard deviation. Okay. So at age 7, Jordan is 51 inches tall. She has a Z-score of 1 standard deviation above the mean. 1 full standard deviation above the mean is quite significant. Okay. And I can compare that to Zane's age, where he has only a half of a standard deviation above the mean. So the standardized heights tell us where each child stands in the distribution of his or her age group. So we could say that because Jordan is 1 standard deviation above the mean, that she is taller than Zane, who is only a half of a standard deviations above the mean. So it's a way for us to compare data that naturally we wouldn't compare, because you're not going to compare a 9-year-old with a 7-year-old or a male with a female. Most of the times you wouldn't do that. Okay, so let's take a look at an example here and talking about the standardized test scores that we were back at. So we have this data, and what we need to do is find the standard mean. So it says find the standardized score for Lionel, who earned a 67 on Mr. Pryor's first test. Interpret this value in context. So this point right here is the value that we are talking about. This is poor Lionel's score. Okay, so what we want to do is find the Z score. Okay, and all we do is put a Z and we write equals. And again, that's the value minus the mean, all divided by the standard deviation. Okay, so this would equal, the value is a 67. That's his score right here. Okay, minus the mean. The mean is 80. Okay, so minus 80 all over the standard deviation, which is 6.07. Now, when you do this, you can see 67 minus 80 is already going to give us a negative value. So this already shows you that this is going to be below the mean. Okay, so when we go into Desmos, and we can enter that in, if you hit the fraction bar first, it'll bring the fraction up for you. So 67 minus 80, and we're going to divide that by 6.07. Now, very important here. We need to make sure that we round to 3 decimal places. Okay, so I'm just going to copy and paste this so we can talk about this on this slide here. Okay, so when I'm every single time, and I should write this down, the Z score, okay, is always rounded to 3 places. Okay, so we have a Z score here, which was negative 2.141, but because this is a 6, it's going to bump that up to a 2. Okay, so it says to interpret the value in context. So because the Z score is negative 2.1, here's what we will say. We will say Lionel's score is 2.142 standard deviations below the mean of 80. So again, notice I didn't put it as negative 2.142 because I used the word below. So when we ask to write and interpret the value in context, you're going to tell me whether it's above or below the mean, and finding that Z value. So again, we're just working on finding the value. We'll do a lot of things with this, like I said back in chapter 6, 7, and 8. So you got an Edulastic assignment to work on. Again, ask questions if you're not fully sure of something.